So whether you've just started learning algebra or you're 2 years deep into calculus and such, you've probably noticed that trig has a tendency to pop up everywhere. I mean literally everywhere. And if you're like me, you probably don't like trig very much, and it probably has a tendency to hide away in the back of your head. I mean, sure, we've all heard of soh-cah-toa, which is, admittedly, an incredible useful tool when you're trying to remember differences between sine, cosine, and tangent. And another trick you might know is all students take classes, which helps you remember which trig values of a unit circle are positive. Speaking of which, the unit circle, 3 words that I'd probably be perfectly fine with never hearing again for the rest of my life. Because if you're like me, you've probably seen enough trig to know the sine of 60 off the top of your head, but again, if you're like me, you probably also have a bad habit of sketching out a teeny tiny triangle on the edge of your paper just to double check that it is, in fact, root 3 over 2. Which it is. And then you have to erase it because, well, frankly, it hardly looks good to have a basic identity triangle drawn into the margin of your calculus notebook. Well, fear no more, because I've recently come across a handy little trick perfect for early trig learners and veterans alike. It's perfect for quickly getting the basic unit circle values. So how does it work? Well, first you have to make a little chart like I've drawn with 0, 30, 45, 60, and 90 degrees along the top. Then fill in the sine row starting with 0 over 2, 1 over 2, 2 over 2, etc. Then do the opposite for the cosine row, 4 over 2, 3 over 2, etc. And now for the magic part. Square root the numerators of everything. And voila! Simplify and you've got your values. Unconvinced? Let's check. Sine of 0 we know is 0, and cosine of 0 we know is 1. And if you simplify root 4 over 2, you get 1, and so it works. Joke time! Why did I divide sine by tangent? Just 'cause. Ha 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 ha. Speaking of sine, tangent, and cosine, we all know that secant, cosecant, and tangent are just the inverse of the 3. But did you know that in the Dark Ages, before they had calculators, there were other notations for combinations of sine and cosine? There was versine, vercosine, coversine, haversine, hacoversine, exsecant, and others. The most commonly used notation was versine. Using these notations made calculations back then easier and way more accurate. They allowed for significant figures to be preserved, whereas continually using sine and cosine would result in the buildup of errors, which is not good. To be honest though, I'm kind of sad that we don't use these anymore. I mean, havercosine? That just sounds so cool. And lastly, pick up your pencils because I have a question. Can you prove the existence of tangerine? Cause I can. It's sine of gerine over cosine of gerine. Ha ha ha. Okay, I know I'm mad, but you know what they say. Math puns are the first sign of madness. Anyone? No? Okay. Thanks for watching, guys. Please like and subscribe for weekly uploads.